this is where we were last time. And based on labs, most of you already know this. We know how to get information out of the computer with a print. And remember, whenever we want to actually display something, a value from within the computer to us humans, we use print. Always print. Never rely on Colab's funny thing of showing you a last value that's just there. And we already know how to get input into the computer like this. All right, I just inputted the value ASD. I didn't do anything with it, but that's what I did. Now, warning, or the value, like the string I have in the input as the argument to that function, it gets displayed, but on Caddis, you're never going to want to put anything in between there because that gets added to the output of your program, which will then be wrong, just as an FYI. And as trivia, what is the type of the value that I just entered? It's not a trick question. You all should know this. String. It's always a string, no matter what. And as soon as you try to pretend it's not, you're going to have a bad time. Now, fortunately, if it's possible, it's actually relatively simple to change something from a string to an int, for example. And we saw that. Here, let's do this. My inputted value, okay, and then we'll do print my inputted value, and then print there. Now, there we go. What did I do? Well, I inputted the value once. I put the value 11. And then the second line of code, I converted the value stored in my inputted value, converted it to an int, and it only worked because it could convert it to an int. And I stored it in another variable called my input but int. Then on line 4, I printed out the value of my inputted value, which is 11, but its type is a string. Then on the next line, I printed out the value of my input but int, which is from line 2 where I converted it. And its type is int. Be aware, if you're saying, but you converted it to an int, why is it not an int here? It's a string here. Well, yeah, because I never changed what my inputted value was. I took it, converted it to an int, and then put it in a new variable. But my inputted value itself was left alone. That's important to be aware of and understand. Okay. And we'll skip that activity for now. So the type of inputted values, it's always a string. And that's what I just showed you there. And I warned you that this could become a big problem because if I try to do var1 equals input, var2 equals input, print var1 plus var2, whoops. We get 11. Why? Well, I inputted 2 strings, and when you use the plus sign on strings, it concatenates the strings. If you expected to get 2 here, you're not crazy, but you didn't add integers together, you added strings. If you really wanted them to be integers, you can convert them to integers a variety of ways. You can make a new variable, var1 but int equals int of var1, and var2 but int equals int of var2. And now, there we go. It adds them together as integers. Cool. Any questions about what we've seen here? We've kind of talked about this a bunch in lab and in lecture already, but just kind of hitting the point a little harder right now. Okay. And we can convert between types. We can do it as long as it makes sense to do so. If I were to take the string, when I run this, I'll have 3 variations of 11. One will be the string 11, one will be the integer 11, and the final one will be the floating point value, but it's just 11, 11.0. So we have 11, and I converted the 11 from a string to an int, and then, I mean, hell, I could have done this. There, now I converted the string 11 to the integer 11, and then I converted the integer 11 to the float 11. Before I did string, int, string, float, but I could do it in any combination I want. It doesn't matter. But the problem will arise, and I can go back too, like equals stir of zxc. Except let's print this one out. That's actually interesting. When I converted it to a float, it added that 0.0, and then when I converted the float back to a string, it includes the 0.0, which is kind of neat. Makes sense, I suppose, but kind of neat. We can go all over the place. The only time this is going to be an issue is, of course, if I'm doing hello, and I say convert the string hello to an integer. Well, that doesn't really make a lot of sense, does it? That's not a thing. Any questions about any of this? The changing types and whatnot, being very careful and aware of what our types are. All right. Okay. Yeah, we'll give you this activity. It'll give you a few minutes to do this. Just work on this activity real quick, just as a way to make sure you're used to playing around with the variables, being aware of the types, converting types, and so on, and doing the calculations. So I'll give you a few minutes to work on this and see if you can get it working. Yeah.
So, because it's a float value, it'll spit out like a certain number of decimals after the point. Is there a way to ask it to round it to 2 decimals or to only show the next 2 decimals?
Yeah, you can say and there we go. This is how you use it. And I guess 2 would specify the decimal places. I'm not doing this to be mean. I'm doing this because I can't remember how you use the function. So we can do like round to 3 decimal places. Oops. There. For the fun of it, we rounded. Did anyone do theirs a little differently than mine? Or do you more or less have what I have? Here's how I did it. I read the input, but I know it's a float, I know it's a string, so I immediately convert it to a float and put it back in the same variable. I could have made another variable, but whatever, I just overwrote the original one. I also could have done that on one line of code if I wanted. What I mean is I could have done this, get rid of this line, and then just that'll work just fine. Did anyone do it like that? Were you immediately, yeah, there's nothing wrong with doing it like that. I know I say I like each line of code to be as simple, like one thing at a time. But this might be an example where I really wouldn't care because it's all about reading the input anyways. But doing it one way or the other doesn't matter. They're functionally the same thing. Did anyone do anything like markedly different? No? Can anyone think of a way I could improve this code? Not necessarily functionality, but in terms of, readability?
Add notes.
Pardon?
You could add notes.
Like comments or something? Yeah, we could do that. You know what I was thinking? I was thinking more something along the lines of this. There. What did I do wrong? Oh, because I didn't. How did that happen? There. There we go. I made it a comment. I made it a constant. Should I have done that? It doesn't really matter, but I think it makes the code a little bit easier to understand because, sure, based on the context of the variable names, it's pretty obvious what that's doing. Something from pounds to kilograms. Obviously, that's, to convert. But there's no harm. If anything, it's definitely beneficial to make your code even more understandable by using a constant. Here, the value of using the constant is to give like a name to that important value. If you just saw 0.453592, I mean, unless you happen to know that that's like the ratio of pounds, kilograms, you'd be like, what the hell's that? This makes it more explicit as to what it is. If you did it with a did anyone in here do it with a constant? No? Yeah, one person, two people, well done. If you didn't, it really doesn't matter. But at this point, I'd say this is more readable. And more readable code, that's correct, is better, I'd say. All right. Any questions about any of that? Okay. All right. So scripts and program files and what we've been doing on Colab are great ways to organize several statements of code, but eventually you're going to find yourself rewriting the same code over and over and over and over and over again, or maybe copying and pasting, fine. But the trouble is, this is a pain in the ass, and it can introduce errors in a way where, like, if I keep repeating the same code, but maybe there was like an issue where I copied it the one time, something gets out of whack, and it becomes harder to maintain. Suddenly I've got all this code doing the same thing, and if I got to change one thing, I got to change it everywhere. It becomes a little bit of like a logistical nightmare, a little bit complex when you've got like the same code that needs to run over and over and over again. So this is where functions come in. Now, if you had lab yesterday, you're all well aware of functions. You've been using functions. You've used print, type, input. Those are functions, but you didn't have to write those functions. Those were functions that Python gave to you for free. Raise your hand if you use the print function. Of course you have. Do you understand like what it does? When you use it, it displays something to you. Yeah. Do you know how it works? No. Did you? Do you need to know how it works in order to use it? No. I mean, you think about it, that print function is probably doing a hell of a lot of heavy lifting. You figure like it's got to go and know like, okay, turn on which pixels on your screen, like what the hell? Like, okay, the value is a 1, I have to display a 1, how do I do that? There's a lot going on. Thank God we don't need to think about it, we just call the print function and it outputs for us. Thank God, it makes the things way easier. So functions have a lot of value, and one of them is it facilitates abstraction really well. What I mean by this is, you want to print something out, call the print function. How does it work? I don't care. It just works because I know it works. I don't need to know. Raise your hand if you drove here today. Really high, I want to see. Okay, how many of you know exactly how every part and everything in your internal combustion engine works? Yeah. Do you need to know though? No, because that's not how you like interface with your car. You just sit in, you turn it on, and you go. You don't need to know all of that stuff in order to drive your car, which is great, thank God. That's, you interact with your car at a higher level of abstraction than its actual underlying parts, which is a good thing. We are interacting with the print function at a very high level without having to know how the hell it works on the inside, which is nice. Now that was a function that was given to us. We can make our own functions. Now if you're writing your own function, chances are you know how it's going to work because you're writing it. But as you start writing more complex code, you're going to end up with like layers of abstraction where you keep getting higher and higher and higher and higher away from like the lowest level function. You'll see what I mean as we go. So here is how we can define our own function. Okay? Def is a very special keyword. Anyone want to take a guess what it stands for? Yell it out. Define. I've actually never checked this, but I assume it's defined, but maybe it's not. I don't know. And then we have what we call the function. It follows the same rules of naming conventions as our variables. So I'm calling it Celsius to Fahrenheit because this is a function that's going to convert Celsius to Fahrenheit. Then you have your parentheses, and then you have what we call the parameter list. however many like parameters this function can take. With this particular one, I'm just taking a value in Celsius that I want to convert to Fahrenheit. So I only need one value, temp in Celsius. And then we need the colon. The colon is very important. Don't forget your colon. That is the top line is like your function, what we call the signature. This is its name. These are the parameters it's going to take. Then within the body of the function, you indent, and then all of the lines of code you want inside that function are indented. If you want to stop writing code inside the function, you unindent and you carry on. I'll show you an example of that in a moment. And at the very end of your function typically, I don't know if typically is the right word, but often your function returns a value. Functions that are what we call pure don't have side effects. Basically, I give functions information, and the function gives me something back. Right? I'll show you exactly what I mean by copying this. So, there. I've defined the function. Before I hit run, it won't know what it is. I hit run. Okay, now Python knows there's a function there. Now I want to call this function. Uh, 22. I hit run. Great. So first of all, notice that I wanted this line of code to run, so I unindented. And the way Python would do this is it would start at the first line of code and go, oh, hey, that is a function definition, so I'm just going to skip over that. Oh, this is the first line of code I'm really going to run, which is go to that function. All right, it goes, whoop, back up here. Based on, I haven't even really gone into functions, but I think this is pretty intuitively designed. Based on what you see here, what value do you think temp in Celsius takes when this function gets called? 22. Why? Well, first, that's how it works, but your intuition was probably like, well, I don't know, the 22 is in the parentheses, and that's in the parentheses, so well, why not? Then the function runs itself with temp in Celsius being 22. When it finishes, it'll have some value, and it returns the value to where the function was called. So this function, when I run this code, it starts at line 1, goes, okay, it's a function definition, whatever, I'll remember where it is. Ah, here we go. Here's a function call. Let's go calculate the function. So Python jumps up to line 1 where the function was defined, assigns the value of the parameter, does the calculation, and then when it's done, we have a value stored in the variable called temp in Fahrenheit. I can't access this variable directly from anywhere that's not within that function. If I were to try to say print temp in Celsius, nope, this pop-up window is really annoying today. If I were to try to run this, it's not going to work. It's going to say, what the hell is temp in Fahrenheit? It's because this is out of scope. It's saying temp in Fahrenheit is not defined. I don't know what it is. And you're going to look at this and be like, it's right there. It's only defined within that function. As soon as the function's done, it's gone. The computer deletes it. So if I want a value from inside that function, I need to return it. So we return the value, meaning after all of this is calculated, the value stored in temp in Fahrenheit is returned, and we're going to store it in the variable f. So f, there we go. Cool. So here, I gave the function the value 22, and the function gave me back the value 71.6 that I printed out on the next line. This function had no side effect. We're going to learn more about side effects a little later in the course, but the side effect that we're most familiar with at this stage is printing out. This function didn't print anything out. I printed the value out, but I printed it out outside the function, which is usually what you want to do. You don't really want to do any prints or inputs from within functions. You do that outside your functions. If you say, well, I really want my function to print out the value of the temperature in Fahrenheit, don't do it. Return it, then print it out like I have it here. Similarly, if you're like, well, I want my function to ask for input, don't do it. Get the input, outside the function, give it to the function, get the value back, and then print it out. This is the better way to do I/O with functions. Don't do it within the function, do it outside the function. We'll learn more about why we like it this way as we go throughout the course. But input and output are side effects. Those are harder to test. That's where errors get introduced and things get weird. So there we go. I gave the function a value, it gave me back a value. I could give the function several values and it can give me back kind of several values. Really, it'll only ever return one value, but more on that later. So any questions about what you see here? Now I want to be very clear about something. The top part, where def, that is the function definition. Python can't run that until we call the function. I have to define the function once, and after it's defined once, I could call it a billion, trillion, kabazillion times. All right, I just called it for the same value every time, but it's defined once. I can call it however many times I want with a different value. So this is the definition of a function. This is me calling the function. All right. So the above example defines a function that converts the temperature from Celsius to Fahrenheit, and the details on all the parts will be discussed as we move through the topic. But you already have a pretty good sense that, you know, a function is a group, collection of statements that serves a single purpose. That's an important thing. You could write a function that does whatever you want, but usually we like to have each function be like very single purpose. This function does one thing. Obviously, the one thing might be several lines of code, but like it's like a functional unit of something. Like this is a calculation of Celsius to Fahrenheit. Sure, there's a couple of lines of code in there, but what does it do? It converts Celsius to Fahrenheit. Print. What does it do? Well, there's probably a hell of a lot of lines of code inside that function, but what does it do? Well, it displays something to the screen. Calling a function, well, we call it like this, right? After the function is defined, we simply write the name of the function, open parentheses, and give it whatever arguments we want. Here's a note. Often, people mix up the word parameter and argument all the time. I'm going to do it in this course. You're going to do it a bunch. Most people use these words interchangeably, but they actually do have different meanings. And I'm going to do my best to try to be as precise as possible, but I'm probably going to mix it up. Mixing it up probably won't create an issue for you because based on the context, you'll know what I'm talking about. Parameters are the variables in the signature line of the function. It's the variable. Arguments are the values we pass to the function. So the arguments are the values that we give to a function, and the parameter is the variable where that value gets stored. So there is a difference. However, a lot of people use these words interchangeably. I'll probably do it. You just know what it means based on the context of what we're talking about. So with this function defined, I can call it however many times I want. It's always important to test your code. So whenever you write a line of code, hit run, make sure, did it do what you want? If you're wondering, well, how do I tell? I don't know, can you print out the result? Does it make sense? So whenever we write a function, we want to test it out, right? So here, I tested 0, well, that's 32. Negative 40 is negative 40. I ran it a couple of times. The results seemed good. Okay, good. I tested it. Good. It's always important to test your code. Writing code is one thing. Writing correct code is a whole other thing. When we call the function, Python executes the statements within the function in order, one line at a time, just like every other chunk of code we've written so far. And functions are really great because, first of all, they allow for the reuse of code. I can define a function once and call it a bajillion times. It doesn't matter. With the Celsius to Fahrenheit example, sure, it's only a couple of lines of code, but functions can become bigger. And I don't want to rewrite that code all the time. I could just call the function. It's great. I'm in great shape. I define it once, call it however many times I want. Maintainability, like if I had the same chunks of code all over the place and I have to make a change, I got to change it everywhere. Where now, if I have a function where it's written once, and I call it a bunch of times, if I want to update that function, I only need to update it in one spot. It's great. And readability, right? Kind of like constants, where constants are a great way to give a value a name. Function names are a great way to give a name to some functionality, right? So Celsius to Fahrenheit is a lot easier to recognize than a calculation that's like c times 9/5 plus 32. We've been talking about converting Celsius to Fahrenheit for a few days, so you might look at that c times 9/5 plus 32 and know what it is. But do you really think that if this was like 2 weeks ago and I said c times 9/5 plus 32, probably a good number of you would be like, what the hell's that? What is that? We know what it is because we've been talking about it, but you know, it's kind of like a mystery calculation. Well, with the function named Celsius to Fahrenheit, you go, oh, that converts Celsius to Fahrenheit. It's pretty obvious. It's named what it's doing. And like I was saying, it facilitates abstraction. This is going to become clearer as we go, but it goes back to the point of you didn't need to know how the print function worked in order to use the print function, which is nice. So function parameters. Anyone have any questions before I keep going? Am I going too fast, too slow? Are you bored? Are you confused? You don't know? All right, so notice how the function Celsius to Fahrenheit had a parameter called temp in Celsius. That was a thing in the parentheses right here. A parameter is just a fancy word for a variable. But it's a variable that gets assigned when I call the function. When I call the function with a value, I give the function an argument, that variable gets assigned that function. So parameters are a way where I can pass information to the function. That's what they facilitate. Like, imagine I wrote a function. So the reason we have the parameters is we want them to be we want our functions to be general. We want them to be general purpose, right? Like if I told you to write a function that converts 20 degrees Celsius to Fahrenheit, you can do that, but that's pretty useless. The function will only ever convert 20 degrees Celsius to Fahrenheit. No, we want to be able to convert an arbitrary value in Celsius to Fahrenheit. So that's where the parameters come in. Because, like, okay, write a function to convert 20 degrees Celsius to Fahrenheit. Okay, so we can do that. Let's do it right now. There, I wrote that. Every time I call this function, it's going to give me back what 20 degrees Celsius is in Fahrenheit. And then I say, okay, now calculate 30. And you're like, okay, all right, well, that's easy. I guess I can just do this. Right? There we go. It'll work. And then I say, okay, now 40. And you're like, okay, come on. Well, yeah, this is obviously silly. This is where the parameters come in. It allows us to be far more general by being able to pass an arbitrary value or arbitrary values. Functions can take multiple parameters if needed. Cool? Okay, yeah. All right. Yeah, rather silly. So yeah, they're just variables. Yeah. Now, if this function thing is throwing you off, raise your hand if you finished like grade 9 math. Maybe grade 10. I don't remember when you learned this like syntax, f of x. Right? If I gave you the function f of x is equal to x times 9/5 plus 32. Well, based on what we were just talking about, we know that's Celsius to Fahrenheit. Fine. That right there is the definition of a function. It is. No ifs, ands, or buts, it's a function. But that's just the definition of a function. Right? If I say, what's the answer to that? You go, well, what's x? You can't solve that until I give you a value for x, right? This is just the definition in the same way. And I'm not making like a tenuous comparison here. It's literally the same thing. That's the definition of a function in the same way that that's the definition of a function. The syntax is a little different, but they actually are the same function in terms of what they're calculating. Now, I like this function better because the function's not called f, it's called Celsius to Fahrenheit, which is a hell of a lot more descriptive than f. Mathematicians are lazy when they name their functions. And the variable, the parameter, was x. Well, no, I call it temp in Celsius, which I think is a much better parameter name, a better name for a variable. But that's just the definition of a function in the exact same way that this is the definition of a function. Now, if you actually want to calculate anything, you call the function. You calculate the function by passing the function a value. If I say, okay, well, what is f of x when x is 20? Well, that's 20. You plug in the 20 for x, you start doing the calculation, you work through, you get a result. There we go. It's the same thing. You define it, but we can't do anything with it until we actually call it and give the value of the parameter, or give the parameter a value. It's the same. So if you've been scratching your head with functions, you might be overthinking it. And this is such a common mistake new programmers make. Is they assume, I'm going to tell you a secret, programmers are stupid, okay? They can't do anything complicated. They have to do everything in the simplest step at a time. Every line of code better be the simplest little calculation ever. We do a lot of these little calculations to solve complex problems, but I can't do anything more complex than like one thing at a time. It's too much for me. It's too much for any programmer out there. But often new programmers think like, oh, it must be more complex than this. I need to like, they end up working way too hard. No. Keep it as simple as possible. There's obviously an art to looking at a problem, breaking it down until it's little parts, and then implementing the little parts to solve the whole problem. Yeah, that's a skill we got to develop. But a lot of people, like they try to like mind muscle their ideas way too hard to make it work for a problem. Chances are you're overthinking things. Slow it down. Think like a stupid programmer. One thing at a time. Don't overcomplicate things. New programmers so frequently throw themselves off because they're trying so hard to make it more complex than it is. The good news is oh, we're frozen. Let's see if we can fix this again. There we go. There we go. Who knows how long I was frozen for? But, yeah. Don't work too hard. You got to keep it simple. Don't try to force it just one step at a time. Remember, programmers are dumb. And I want you to be dumb like the rest of them. In the best way possible. So, okay, so It's the exact same idea. When you define a function and then you use the function, it's the exact same idea. The only difference is the syntax. One's in the math syntax we've been used to since we were this big, and the other is Python syntax because this is Python. Do we have any questions about this general idea so far? So the execution of a function. So here is a very simple function. Square of sum. It is a function that has two parameters. So when I call this function, I must give it two values. And what does it do? Well, it adds the numbers together, and then it squares the number by multiplying it by itself, and then it returns the value of the sum of the square, or the square of the sum. That's how it goes. Now, very quickly, I'll just show you. So I define the function. If I call square of sum with not enough parameters, it's going to say you're missing parameters. Like you didn't give it the arguments. If I give it 2, well, it's still going to say I'm missing one positional argument. I need another. This function needed 2, you gave me 1. And then, of course, if I do if I give it more, it's going to say, I needed 2, you gave me 6. So it matters how many there are and how many you give it. But back to here, if I were to call this function with the arguments 2 and 3, Python handles the execution like this. 1, Python will first check to see, does it know of a function called square of sum? If I were to go down here and start to call a function called this function does not exist, 8, 1, whatever, and I call it, it's going to say, what the hell is this? The first thing it does is make sure, is this function defined anywhere? In this case, this function isn't defined anywhere. I'm trying to call a function called this function does not exist, but it doesn't exist. It was never defined. Here, if we run this code, well, here, I call square of sum. Well, here, let's do it like this. There, that's a little nicer. When I call square of sum, it goes, yes, I knew that. Because what happens is when I run this block, it goes, oh, okay, there's a function called square of sum. I'll remember that. Great, great, yeah. Oh, call the function square of sum. Okay, so we go here. Python then takes the values supplied when it was called, the arguments, 2 and 3, and assigns them to their respective parameters. A becomes 2, B becomes 3. If you're wondering, well, how did it know where the 2 goes to A and the 3 goes to B? It's because it's no more simple than just A was the first one and 2 was the first one and 3 was the second one and B was the second one. Like it goes based on their position. The sum of A and B is calculated. So 2 plus 3 is 5. That gets stored in C. C is 5 times 5. Well, that's 25. We store it in D. And then we return D. So when this function is called, who wants to be my function? I need a volunteer. You'll be the function. Okay, you're the function called square of sum. I'm line of code 6. Okay? And I go, okay, I need to call the function square of sum. You exist, you need 2 values. Here's 2, here's 3. Catch them. Perfect. Now, do the calculation. Good, well done. Now you have the number 25, right? I mean, I don't know he has 25. He's still got it. You got to give it back to me. So return the value to me. Awesome, I have it. What do I do with it? I store it in the variable result. The last thing that'll ever happen on any line of code is the assignment. So the function gets called, everything gets calculated, the value gets returned. Effectively, square of sum gets replaced by the value that it returned, 25. That gets stored into result, go down to line 7, print out the result. That is the execution. If I were to do it again, The lines of code Python will go through will be like this. Okay, it runs line 1. Okay, it's a definition of the function. Okay, 2, 3, 4, 5, 6. 6 goes back to line 1, 2, 3, 4, return to line 6. Store the result. Line 7, print out the result. Line 8, oh, call the function square as sum. Jump back up to line 1, 2, 3, 4. We're done. Return to line 8. Store the result, print it out. So now the execution is kind of like jumping all over the place, but it has a very clear order in which it goes. And like I just said, if I give too few or too many arguments for the function, it's going to get mad at you. Every function call returns a value. All right? Whether you like it or not, every function returns a value. In this example here, it returned a value. I wrote return D. In Celsius to Fahrenheit, it returned a value. It returned the temperature converted from Celsius to Fahrenheit. Every function has a return, even if I don't write one. There's a return that gets added by Python. If you say, I don't want my function to return anything, usually they do return things. That's the whole point of function. They get information, they give information back. But if I don't write a return, Python sneakily goes and adds one for you, whether you like it or not. Every function must return a value in Python. When you specify what you want to return, like this, for example, Python listens to you. If you don't specify, Python goes and adds this to your code without you noticing. You'll never see it, but it does. Return none. And none is a super special value in Python. Other programming languages have the exact same idea, but they might call it something different like null. But it's a very special value that has a very special meaning. It is a value that means nothing. Now, I don't mean it means literally nothing. I mean that it's a value that is a stand-in to mean, oh, this function didn't return anything. It did, though. It returned this. Imagine it's a box that the function gave back to me, and then I go, oh, well, this box means nothing. That's really it. It's a weird idea, but it's going to come up a lot, and it's going to become second nature to you and make perfect sense. But it is a value that if a programmer is watching their code, and they see, oh, I got the value none back, that means it's a stand-in to mean like nothing. So none is a very special value. And what's neat about none is it actually has its own type. Integers are a type, right? And what values can integers take on? 1, 2, 7, a billion, negative 22, whatever you want, right? There's a lot of different values an integer can take. We're going to learn about Booleans soon, which is another type. And Booleans actually only ever take on one of two values, true or false, 1 or 0, which is pretty neat. None type is a special type where anything of its type must take on one and only one potential value, and it's none. So it's kind of interesting. Yeah, so that's what that is. And for fun, do this activity later. But we'll pick up here on Tuesday. Whoops.